Hello, everyone. I'm Augusto Esteves. Thanks for the introduction. I'm presenting the ATB Video Coding Framework, which is a video coding framework to quantify and classify epistemic strategies in tangible problem-solving tasks. So I'll explain what this all means in a second, hopefully. I want to thank you all for coming to a session that has theory in the name, and to my collaborators from TEI in the Netherlands, Simon Fraser in Canada, and Eunice in Korea. So we all know that both users and designers continue to be drawn by the enduring allure of physical interaction. And it's understandable. Tangible systems have almost a limitless potential for interaction, with lots of cool projects making their way into the news and the public domain. So it's pretty easy to get excited about these systems. But as a computer scientist, it remains fairly challenging to measure and quantify task performance in tangible interaction, and to systematically account for the underlying properties or qualities of tangible systems. So it's hard to measure this attraction and allure. So the question we ask in this session is why to use theory? In the work I'm presenting, we believe theory can help us develop performance metrics that focus explicitly on the properties of tangible systems. So the next question would be how to use theory. So how can we use theory to ground, for example, system evaluation, or in our case, how can we use theory to ground a video coding framework for tangible interaction? So we know theories such as embodied cognition help us understand how interface elements and their inherent physical properties, the abilities to be stacked, to be sorted, to be annotated on, can be leveraged to simplify or aid performance in computer-mediated tasks. And we also know one idea from embodied cognition, which was first introduced by Kirsch et al., that classifies actions as either pragmatic or epistemic. A pragmatic action would be an activity that users conduct to directly move towards a desired goal state. So Kirsch used Tetris as an example, and a pragmatic action would be moving the piece directly to where the user wants to place it in the screen. An epistemic action, on the other hand, would be an activity that alters the task so that the user's cognitive processes are faster, more reliable, or less taxing. So instead of mentally rotating the piece on screen to see where it would fit on the bottom of the board, experienced participants would actually physically rotate the piece on screen so that this process is easier, faster, and less taxing for them. So while Kirsch used this idea in a purely digital game, the Tetris, Antle et al. Was arguably the first to apply to tangible interaction, using epistemic action as a metric to quantify task performance in a tangible and touch interfaces to a jigsaw puzzle, and she did it using a video coding analysis. And she came to the conclusion that the tangible representation afforded more natural and efficient epistemic strategies, such as clustering pieces together to improve visual search later on, and also observed that users would use the elevated edges of the board game to actually frame their puzzle as they were solving it. I myself have used it to compare. I've used epistemic actions to compare user performance to a game of 4 in a row using tangible, a touch, and a mouse interface. And I used video coding analysis and also automatic logging of these pragmatic and epistemic actions to do so. And I observed that epistemic actions were really important regardless of the interface, but they were more efficiently performed in the tangible system. So while this distinction between pragmatic and epistemic actions seems like a very suitable metric to evaluate tangible systems, it's still an evaluation metric that has very low level of granularity. So even though epistemic strategies are very specific and contextual to the problem users are facing, normally the use of epistemic actions is very broad and general, reducing them to a single categorical label when we're using them as this metric. So to address this, I'm presenting the ATB Framework, which is a video coding framework based on a detailed classification scheme for epistemic activity. The first goal of the framework is to be a mechanism to evaluate tangible systems in terms of the type and diversity of epistemic actions they support, and also to understand the impact of epistemic actions in more traditional performance metrics such as completion times or error rates. So the remainder of the presentation, I'll explain how we developed the framework, how we used it and how other researchers can use it. And also a study we did to initially assess the framework's reliability, validity, and predictive power. So to develop the framework, we did a literature review using these 3 terms on both ScienceDirect and Google Scholar. We kept the first 60 results for further inspection. We also looked into papers that referenced Kirsch's seminal work on epistemic actions, and we also looked at them for these keywords. After this process was completed, we were able to retain 78 publications from the field of maths, cognitive science, HTI, and design, and we compiled 335 quotes that could be interpreted as epistemic actions. This is an example of one of the quotes we gathered from this process in how someone prepares their workspace by separating different pieces of the task so that it's easier to access them later on. At the end of this literature review, we gathered all these ideas into 20 types of epistemic action, and we grouped them by actions performed with task artifacts, so artifacts you design for your tangible system that are tagged with fiducials or other forms of identification. Tools that, I mean, something that already exists in the user's environments, such as pen and paper or a ruler, that's something that's generic and can be transversal to different systems, and the user's own bodies. So it looks a bit daunting, but I'll explain it. So to use the framework, we initially use an approach that was introduced by Antle et al. At TEI 2 years ago, in which every action is classified as either a direct placement when the user uses a task artifact and moves it directly to its final and correct position. So very similar to what a pragmatic action would be. So here you see a user picking a puzzle piece and just moving it to its correct position with no actions in between. We can also classify actions as indirect placements, which are very similar, but in the way to its final positioning, there's some sort of action that occurs. Something that will look like this. So the user picks the piece, does some sort of action, and then places the piece in its final and correct positioning. And lastly, we have exploratory actions, which are done with either the task artifact, a tool, or the body. If they're done with a task artifact, they don't lead to the artifact's final and correct positioning. So an example would be, and then the user doesn't place the piece in its final positioning. We can also classify actions as off-task events when the user is distracted or he picks a phone, someone comes in the room, something that's not relevant to the task. After this process is completed, we look at all the actions classified as exploratory or indirect placements, and we try to match them to one or more of the 20 types of epistemic actions we identified. So again, this is a bit daunting, but this is just to explain how we separated the epistemic actions we identified through epistemic actions done with artifacts, with tools, or with the body. I'll give you 3 examples that will be relevant later on when I'm describing the study we did and what we observed. So the first epistemic action I want to describe is A2. So it's a spatial arrangement of artifacts in relation to one another or the task. So here the user found the corner piece of the puzzle. He places it on the table, so it helps him frame the puzzle as he goes along. We have epistemic action A4, which is sort of this brute attempt to position the piece by force in different positions without considering, without many considerations. And lastly, epistemic action A6, which the user compares the artifact with other artifacts or possible destinations by actually handling the artifact. So now I'm going to describe the study we did to start to assess the framework's reliability, validity, and predictive power. We did an observational study using observing participants doing a jigsaw puzzle, which is a classic problem-solving tasks. We selected this task because there's a large body of work in how epistemic actions using puzzles in both cognitive science and in HTI, especially tangible interaction. We had the 60 participants, 20 from each of the locations where the studies were held. These participants' ages range from 20 to 76, and we actually had a broad group of participants that were not just university students. So our study would start with a spatial ability test to measure each participant's spatial ability. this would be followed by 2 puzzle tasks. The first would be an unmeasured task, which the participants had 10 minutes to solve. The second would be a 15-minute task. That was the main task of our study. And both puzzles were always solved in the same order. They had different images, but they were the same size and the same number of pieces. We also, even though we recorded, of course, we recorded the second puzzle, we would leave participants alone in the room so that they performed the epistemic actions in private without feeling judged. And at the end, we handed them the NASA TLX. So regarding the framework's reliability, we had 3 individual raters applying the framework to all the 60 sessions, so all 60 videos of people interacting with the second puzzle. Each rater was assigned 20 videos, 10 males, 10 females, and had 6 or 7 participants from each cultural backgrounds. And then we had 2 of these raters acting as second coders for 8 of all sessions. From this double-coded content, we observed a substantial agreement when actions were being classified as direct placement, indirect placement, exploratory, or off-task events. Substantial when they were classifying these actions as done with artifacts, tools, or the user's bodies, and a moderate agreement when they were using the 20 types of epistemic action. And the misclassifications actually cascade, so it's understandable how the agreement is growing thinner. Because of the limited number of double-coded content, so we only had 8 out of the 60 videos, we perform additional statistical analysis on all the content from the 3 raters. And we observe very little differences. All the raters had very similar results for direct placements and exploratory actions done either with indirect placements or exploratory actions. They also reported the same number of epistemic actions, so the epistemic actions A1, A2, A4, and A6 were the most common one, regardless of rater. And here on epistemic action A1, we actually see sort of the misclassification where it happened regarding rater 1 and rater 2 and 3. To assess the framework's validity, we contrasted the performance of participants with different genders and different cultural backgrounds. And by using the metrics, by using the results we gather from the spatial test and the subjective task at the end of the puzzles, the variation in the results were what we were expecting for both gender and cultural background. Lastly, we assessed the framework's predictive power by comparing successful participants, those who finished the puzzle in less than 15 minutes, and participants who didn't manage to solve the puzzle in time. We focused on the epistemic actions performed in the first minute of the task because work on spatial problems has led us to believe this is a good place to look for these kind of. So through a linear regression, we actually observed that the aggregate number of epistemic actions performed in the first minute of the task was a predictor for success. So just by looking at the first minute of the task, we could safely understand if that user would finish the puzzle in less than 50 minutes or not. We can actually see that the successful participants did almost twice as much epistemic actions in the first minute of the task as participants who didn't manage to solve the puzzle. Then looking at all the 4 most coded epistemic actions from the 3 raters, we did a multiple regression. And again, we saw that these 4 could be a good predictor for success. On the top, we have the successful participants. On the bottom, those who didn't succeed in our task. And here was where the granularity of the framework came into play, because now you could see individual epistemic actions and how they would impact performance in the user's task. And we could see that epistemic action 1 and 2, so epistemic action A2 being the one that the participants start to frame the puzzle by putting corner pieces or edge pieces, actually was very helpful and relevant for the users in the beginning of the task. We saw that epistemic action A6 was not particularly helpful, so comparing a piece with other pieces of possible destinations wasn't particularly helpful in the beginning of the task. And epistemic action A4, sort of the brute strategy in which you try to trial and error your way into the puzzle in the beginning of the task, could actually be detrimental. So it's not a significant result, but it could indicate that it's actual detrimental epistemic action in this task. So Here it's exemplified how actually understanding the different epistemic actions, we can get a better sense of what is actually helping the users achieve their goals in the task. So taken together, we believe these results are promising. They're initial results, but we believe they are promising. And they vouch for the ATB framework as an instrument not only to record epistemic work, but to reliably identify the most common source of epistemic activity during interaction. And we argue this knowledge is actually valuable for both design and assessment of tangible systems. So in terms of design, I myself presented this work at TEI 2 years ago, in which the tangible system implicitly supported epistemic actions. So as the user would hover the disk above the Connect 4, you would get a sense of the future state of the board before dropping the coin. And we have a more common example with Sudoku. I think this is from the Nintendo 3D, yes? And in which the game was designed so users can leave notes for themselves on screen. So even though these systems already implicitly support epistemic action, we believe that through the ATB framework, we can actually understand what epistemic actions are valuable to support, and we can actually start designing systems that support them. And the same can be said about the assessment. So the way we set up studies for tangible systems can also be influenced by the data we gather from the ATB framework, because then we know how important it is to record what's happening with tools from the environment. In this case would be cans, or how we should set up our study so that it records automatically the body of the user and actions that are done through the body. So in terms of future work that lies ahead, so despite the substantial and diverse group of participants we had, and the fact that the framework was informed by epistemic actions collected from various fields, and thus should be applicable to different problem-solving tasks, we only use one spatial task. So the most pressing work, of course, will be to apply this framework to other problems, to other spatial problems as well. And this will allow us to reinforce, extend, and generalize the findings we had in our study. I want to thank you. I want to say that this material is all on this website. It's also on the paper, this link. And we really strive to create this tool so that we can develop new systems that actually support users' knowledge of interacting with the world. In the way they interact, they already know how to solve problems. They already know how to perform these epistemic actions. We just need to know how to tap into this information so that we develop these systems that can support this very natural way of interacting with physical problems. That's all.
Okay, wonderful. We have time for one or two questions, if there are any questions. No, if there aren't any questions, then I actually have a question. Actually, I have a couple of questions. The first question I have is, you didn't really talk to it, but you mentioned it's more addressed in the paper, but you talked about the reviewer agreement stores, not necessarily corresponding in some cases. And in the paper, you talked about how that's one of your categories was kind of a catch-all, and all of the other categories kind of fell under it. And I was wondering why you did that breakdown. Like, was the A1 category necessary, or was there a reason for having a category that is sort of over a bunch of other categories?
So this was a point that we discussed it. We had several co-authors, and it was something that we were trying to figure out how to create a framework that would respect the literature review we did. So the process in which we created these epistemic actions were always, so we could always trace one epistemic action back to a piece of paper we got from literature review.
Yeah.
So there was a strong epistemic action that was always done with task artifacts. That was the manipulation of an artifact just by itself. So people sometimes want to feel the weight. They want to rotate the piece just by itself.
Yeah.
So because it's a video coding framework, we also want the instructions to be clear. So if you see someone picking a piece and rotating it, it's already an epistemic action in itself, so it's there as an epistemic action. But because it's so central to a lot of the epistemic actions you do with task artifacts, we also wanted so that the framework made sense. So when you see someone picking a piece, you already know it's this one, and then you go down the tree and you say, oh, it could also be this one. But it would make sense when you're using it as a tool. and probably not so much when you're reading it as just as a framework.
Yeah, okay, that makes sense. So I guess that there was that one reviewer who classified a lot with that first category and didn't sort of dig deeper necessarily.
Exactly. So I didn't want to explain where the misclassifications happened because I didn't explain the framework in that much detail because it's sort of but it's exactly one of the big problems was when there were these nested epistemic actions and then the misclassifications would happen because one rater wouldn't feel confident in going a bit deeper and it's fine and it will be still
And maybe a second and sort of kind of related question, because once you start to dig deeper, you get into these very precisely categorized epistemic actions, which worked really well for the puzzle problem-solving task, and now you're thinking about what are sort of other tasks that this framework can be useful for. I'm wondering if you have any ideas or if you can comment on some of the other tasks that you might be thinking about studying next using the framework.
So we feel confident that because the way that we did the literature review, that these epistemic actions will be represented in other tasks. We actually run this study. The study included another task, which was a Pintomino. I don't know if you are aware. It's a game that you have a board that's cut into different shapes, and then you can make so the task would be for people to pick these pieces and put it back in the box. So in order to fit them all in the box, there's only one particular order you can do this. But then at the end of that task actually didn't represent that many. People didn't have that many epistemic strategies during that task because it's such a very simple way to achieve it. So people would just be trying to force these pieces for 15 minutes, and it was a very hard task for them. It wasn't fun. They couldn't tackle they couldn't use any strategy to tackle the task. So in the end, it wasn't a good task to use our framework on. So we are really keen on using it in other tasks, but we feel it should be applicable because of the way we did the literature review. So we didn't focus on a very specific domain on problem solving.
Great. Well, thank you. So if there are no further questions, let's thank Augusto.